Hey there, welcome to Pomodoro Joe for Sunday, October 29th, 2023. Today we're looking at LeetCode problem 458, poor pigs. This is a hard problem. There are number of buckets of liquid, where exactly one of the buckets is poisoned. To figure out which one is poisoned, you feed some pigs, some number of pigs, some of the liquid to see whether or not they die. Unfortunately, you only have minutes to test, number of minutes, to determine which bucket is poisonous. You can feed the pigs according to these steps. Number 1, choose some pigs to feed. Number 2, for each pig, choose which buckets to feed it. All right? The pig will consume all of the chosen buckets simultaneously and will take no time. Each pig can feed from any number of buckets, and each bucket can be fed from any number of pigs. All right, that just means that we can use the same bucket to feed multiple pigs. Okay, wait for minutes to die number of minutes. You may not feed any other pigs during this time. After minutes to die minutes have passed, any pigs that have been fed the poisonous bucket will die, and the others will survive. Repeat this process until you run out of time. Given buckets, minutes to die, and minutes to test. Return the minimum number of pigs needed to figure out which bucket is poisonous. Okay. Oh man, this is a hard one. Let's look at the example, that might help. So we have 4 buckets. Minutes to die is 15, and minutes to test. I think the first thing I'll want to do is figure out how many tests we can perform. So minutes to die is 15, minutes to test is 15, so that means we only get 1 test. Now we have 4 buckets. We have to figure out which one of these 4 buckets is poisoned with only 1 test. How many pigs do we need? Well, we can't do it with just 1 pig, because if we feed that pig 1 of the buckets, we still have 3 buckets we don't know whether or not they're poisoned. If we have 2 pigs, we could feed each pig 1 bucket, but that leaves 2 buckets left out. But it looks like there's a trick here. We feed each pig 1 bucket, and then we feed both the pigs from a 3rd bucket. That way, if 1 pig dies, we know it was the 1st bucket. If the 2nd pig dies, we know it's the 2nd bucket. But if both pigs die, we know it's the 3rd bucket. And then we keep 1 bucket out, and if no pigs die, then the one that we didn't feed any pigs with, that's the poison bucket. So we can do this with 2 pigs. Okay, example 2, buckets 4, minutes to die is 15, and minutes to test is 30. So now we can do 2 tests with 4 buckets. Now, can we cut this down to just 1 pig? We already know we can do 4 pigs with we can do 4 buckets with 2 pigs. Can we do 4 buckets with 1 pig if we have 2 tests? Well, let's see. We could feed 1 bucket to the pig once. If we had 1 pig, we could feed 1 bucket. Then we could feed the 2nd bucket, but that still leaves 2 buckets left out, which means that we can't do it with 1. But we know we can do it with 2. So the answer there is 2. All right. Oh, man. We'll put 25 minutes on the Pomodoro timer here, and we'll get started. So this one is actually really, really hard. So this is kind of the best I can do to explain the solution. I definitely did not come up with the solution on my own. The explanation is mine, and I could be totally wrong, but this is kind of the best I got. Okay, so let's start with some base cases here. Very simple cases. So if buckets, let's see, because we know how many buckets we have. If this is equal to 1, well, we don't need any pigs. It's going to be the poison bucket, so we can return 0. That's just a simple, easy answer. We can do if buckets is 2. Let's see, let's do that. All right, if we have 2 buckets, well, can we do this with 1 pig? We can. We can feed 1 bucket to the pig. If it dies, that's the poison bucket. If it doesn't die, then the bucket we've got out is the poison bucket. So we can return 1. All right, so that takes care of some simple base cases. Now we get to the more complex case. So I'm going to set my result equal to 1 to start with. Now my initial thought for doing this problem might be, maybe we could do some type of binary search on the answer, because I know my max number of pigs would be number of buckets. So I have a maximum threshold. I don't need any more pigs than the number of buckets. But I could do it with less, and I have a lower bound. I know I need at least 1 pig, so I could do this binary search on the answer somewhere between 1 pig and bucket's number of pigs. The only problem there is I need to have some formula for a given answer. I don't really know that formula, at least not yet. Okay, so we're going to set our result equal to 1. We'll return our result at the end. Actually, I'm going to call this something else. I'm going to call this number of pigs. Okay, and we'll return the number of pigs at the end. All right, so here's the best explanation I have. If we're given some number of pigs and one test, oh, let's calculate how many tests we have actually. Let's do that. So number of tests. That's just going to equal this minutes to test divided by minutes to die. And we'll do an integer divide, although I don't know if that's necessary. All right, so that's the number of tests that we can perform. Now, if we can perform one test, then every single pig, we need to have this test be definitive. So one of the pigs has to die, or the poison bucket has to be the one bucket that we leave out. So if we have one test, then essentially every pig will get a bucket, and we can split 2 buckets or 1 bucket among 2 pigs. But at the end of this one test, either all the pigs are still alive, meaning the 1 bucket left out is our poison bucket, or some of the pigs have to have died, and that way we know by combination of buckets which pig died or which bucket was poisoned. Let me go over that one more time. All right, so at the end of the first test, if we only get one test, at the end of our first test, either some of the pigs have died or none of the pigs have died. Now, if none of the pigs die, we know it's the 1 bucket that we left out that was the poison bucket. If some of the pigs die, we need to have formulated our test in such a way that the combination of pigs that died will definitively point to 1 bucket that's poisoned. So at the end of the first test, some of the pigs will be alive, some of them will be dead, maybe. But what are the different possible outcomes for each of the pigs? So at the end of the first test, the pig will either be alive or it will be dead. There's sort of 2 possible outcomes. So for any pig, the pig either survives a test or it doesn't. Those are the only options. The pig survives the test or it doesn't. If the pig survives the test, we can use that pig again in the next test. If the pig doesn't survive the test, well then we can't use that pig again. Okay, let me try this. So we have number of tests. Okay. Now each pig for each test could possibly die or survive. So let's see. So each pig, each pig could die on test 1, or on test 2, or on test 3. So let's see. Or on test number of tests. All right, so let's start with this. Each pig could die on test 1, or test 2, or test 3, all the way up to number of tests. Or the pig could survive all the tests. That is a possibility. Okay, so each pig has tests, or a number of tests, plus 1 different possible outcomes. So I'll write that down here. So again, for each test, if the pig survives, we move on to the next test, so on and so forth. Now, at the very end, the pig could survive all the tests, so we have this 1 extra outcome where the pig survives all of the tests. All right, so these are our different possibilities for each pig. So each pig has number of tests plus 1 possible outcomes. Well, the first pig has number of tests plus 1 possible outcomes, and the second pig has number of tests plus 1 possible outcomes. So what are the total number of possible outcomes? Well, that's the first pig, number of outcomes, that's number of tests plus 1, times the second pig's number of outcomes, that's number of tests plus 1. So if we have 3 pigs, then we have the first pig, number of tests plus 1, times second pig, number of tests plus 1, times third pig, number of tests plus 1. Each one of our pigs has these number of tests plus 1 possible outcomes. So that's how many buckets we can test. So this looks like we're taking the number of tests plus 1 and raising it to the power of the pig, the number of pigs that we have. Now we don't know how many that is, So we'll have to keep checking, well, what's the number that we need in order to reach this many buckets? So let's see, while, I'm actually going to do a little bit of work out here. So this is number of tests plus 1. Or maybe I'll call this number of possible outcomes for each pig. And that's just going to be the number of tests plus 1. Okay, so now, while the number of possible outcomes for each pig raised to the power of the number of pigs, so that's just going to say pig number 1 has this many possible outcomes times pig number 2, who also has this many possible outcomes, times pig number 3. All right, while this is less than the number of buckets. Well, now we need more pigs. If we don't have enough possible outcomes, then we don't have a way to check all of our buckets, so we need more pigs. So the num of pigs, we'll just add one more pig and see, now do we have enough outcomes to reach the number of buckets we're looking for? All right, man, this one is super confusing. It's short code, but very difficult concept. All right, let's run this and see how we do. Now, I'm sure if my math were better, this would make total sense. All right, let's submit this, see if we can pass all the tests. And we pass. And we don't do great. Let's see, we beat 36% for runtime and 11% for memory, so we don't do great. Now, I think part of that probably has to do with my naming here. So I'm not choosing short names, I'm choosing long names. And I have this big block of comment here, which does take time for the parser to go through. We could try something really quick. Let's do this. I'm just curious. So let's replace this with this. Just comment this out. Still works. See if this gives us any kind of boost. And it actually makes it worse. Now we're down to 27%. All right, so we were better with our first one. Let's go back to that. I like it better. It's more explicit. You kind of understand what's going on. All right, and the battery on my mouse just died, so that's perfect time to end it. All right, so I think that's it for me. I wish I had a better way to explain this one. Okay, well that is it for me. If you understand this one, if you have a better way to explain it, I would totally love to hear it. Please leave a comment. And yeah, I would love to hear more, because this one is one that is definitely confusing. Okay, well that's it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.